Hello everyone. Today we are going to prove that there is an infinite number of prime numbers. We will do this using Euclid's proof, a classic proof by contradiction. If you don't learn this proof by watching this video, then that means you will not be a real top G. Now let's proceed. So firstly, let us assume that there are a finite number of primes. This means that we can create a finite set of primes. Let us denote the set of all prime numbers as capital P. If we assume that the number of prime numbers is n, then we can write each of the elements of the set P as P sub 1, P sub 2, P sub 3, and so on and so forth, until P sub n minus 1 and P sub n. Now let us take the number k, which is the product of all prime numbers. This means k equals P sub 1 times P sub 2 times P sub 3, and so on until P sub n minus 1 times P sub n. We now consider the number k plus 1. There are two cases to consider from here. The first case is if k plus 1 is composite, meaning it is not a prime number. This means that k plus 1 must be divisible by a prime number that isn't itself. Because k is the product of all prime numbers, it is divisible by every prime number. Therefore, when we divide k plus 1 by any of the prime numbers in our set, P, we have a remainder of 1. This means that for every prime number in set P, k plus 1 is not divisible by that prime number. Because P contains every prime number, this means that k plus 1 is not divisible by any prime number, except for itself. This means that k plus 1 is only divisible by itself, and 1, so it is a prime number. However, k plus 1 is not in set P, and is a prime number, which means that P did not contain every prime number, which contradicts our initial assumption. Let us consider the second case. In our second case, we say that k plus 1 is a prime number. This runs into the exact same contradiction that we had for k plus 1 being composite. We have the prime number k plus 1 that is not in the set P, which means P is not a complete set of prime numbers. Therefore, once again, we have a contradiction. Hence, both cases lead to a contradiction. This means that our initial assumption must have been false. This means that there does not exist a finite set P that contains all the prime numbers. Thus, the set of all prime numbers is not finite, and so there is an infinite number of prime numbers. Thank you for watching.